Hi, our video today will be on the intermediate value theorem. So there aren't too many theorems in AP Calculus BC that I'll tell you need to know by heart, but this is one of them. So we begin with a graph of an increasing function. So go ahead and sketch that out in your notebook. And the parameter for this function is that it's a function that is continuous. We want to remember all the things we talked about with continuity up to this point. So this function is and must be continuous on a closed interval, which we write in notation as bracket a comma b, close bracket, and it takes on, what the theorem says is that given a continuous function on a closed interval, that function will take on every value between f of a and f of b. And remember, f of a, f of b are y values. So on our diagram, let's go ahead and assign some points to our graphs. So the first x value on the that I'll sketch out here will be the x value of a. Given that this function is called f of x, that would mean its corresponding y value is f of a. And assigning a b value that is to the right of a, we'll pick an arbitrary point right of a and call that b. So what we're saying is that this corresponding point f of b is associated with the x value of b, and that so long as, and I'll use my nifty pointer here, so long as this function is increasing, what I can conclude is that the y values the y values that occur between f of a and f of b must exist at every single value between f of a and f of b, given that this function is continuous, which it is, and that's easy for us to see. So my example for this is, let's say you were, and I'll draw a simple graph here. You have on your y-axis distance, and on your, so a simple time distance graph. And say you started walking home, and in the process of walking home, you walked a constant pace, and within, let's say, 30 minutes, then 60 minutes, you kind of live far, so 60 minutes away from home, you have that you walked a total of, let's say, 8 miles. So 4 miles for every half hour. Is that reasonable? Yes. Okay, so 4 miles for every half hour. And so the question is, during the 1 hour time that it took you to walk home, is it reasonable to conclude that at some point you must have reached a distance of, let's say, 2 miles, or 4 miles, or 6 miles? And the answer is yes. All the lengths that we have between 0 and 8, given that this is a continuous function, which it is, we can conclude that it must take on every single value between 0 and 8, that we must have gone 1 mile before we went to 2 miles, before we went to 3, all the way on to 8. And so that's a physical representation of the intermediate value theorem. At the end, I'll ask you guys if you can think of any other realistic scenarios in which something like that would take place. We're now going to move on to how IVT might be seen in a math problem. So with this next problem, this is a common problem. You might have seen it last year in Pre-Calc Honors. This is going to actually say use IVT. So use IVT, which stands for Intermediate Value Theorem, to show that. So to show that the polynomial function f of x equals x squared plus 2x minus 1 has a 0 on the closed interval between 0 and 1. So the important thing to note with IVT is that the conditions must be true. So we must know that the function is continuous for us to make this conclusion. So do we know that a polynomial function is continuous? And yes, we should know that all polynomial functions are continuous. There's no breaks or steps within that function. There's no asymptotes within that function. That function isn't undefined. So then we move on to say that f of x, so we would have to say we know that f of x is continuous. And so therefore you guys can make a conclusion using IVT, but that it's continuous between 0 and 1. And then now we want to find, well, what is our minimum y value and our maximum y value, and does it show that that the y value achieves a 0 between f of 0 and f of 1? So first, let's find out, well, what is f of 0? What is the left endpoint here? So if I plug 0 into x squared plus 2x minus 1, I get a negative value of negative 1. If I plug 1 in, which is and I'll show you with my pointer here, which is the right endpoint of my interval, I get 1 squared plus 2 times 1 minus 1 is 2. And so we see that there is a sign change between f of 0 and f of 1, that the y value goes from negative 1 to 2. So it's reasonable for us to conclude that there is a 0 that's achieved between those two values. So our conclusion, which we do have to write a conclusion, a sentence, since negative 1 is, or that 0 is between negative 1 and 2, IVT guarantees a 0 on the interval from 0 to 1.